So here's the puzzle we asked. I have to play 3 games of chess against my parents. I have to win 2 games in a row, and my mother is the better player. So either I can play my mother first, then father, then my mother, or I play my father, then my mother, then my father. So which is the best option? So we said in our mathsat.co.uk podcast that one of the best ways to do this was just informally. So we have 2 options. We can either play my mother, my father, my mother, or we can play my father, my mother, my father. Okay? So remember that my mother is the stronger player. So in this situation, we're asked to win 2 games in a row. So to win 2 games in a row, we either have to win the first 2 games, or we have to win the last 2 games. Of course, it's possible we could win all 3. But whatever the case, we must win this middle game. Okay? So given that it's a must-win situation, who would we rather play? The stronger player or the weaker player? Well, of course, we'd rather play the weaker player, which, of course, is my father. So it looks like this option here is going to be the best. But let's think about the other games. We must either play my mother twice, or we must play my father twice. Okay? And if I'm going to have to play a strong player at all, then I'd like to have 2 chances against the strong player. So it looks like intuitively that this situation here, where I play my mother, and then my father, and then my mother, is going to be the one that is better for me. Because I have to win the middle one, which I play against the weaker player, and I have 2 chances, not just 1 chance, against the stronger player. Now let's see if I can actually solve this using some mathematics. Well, that was mathematics which we did. Let's see if I can solve it doing algebra. So in order to win twice in a row, I can either win all 3, or I can win the first 2 and lose the second, or I can lose the first one and win the third. And these are 3 different events. So people that do know any probability theory will know that events is just one thing that can happen. Okay, well, let's write M as the probability I beat my mother. And by that I mean I beat her at chess. So this is the probability I beat my mother. And the F is the probability I beat my father. Okay, so if I win in this first scenario here, where I'm playing my mother, my father, and then my mother, then the probabilities here are just as I've written down, MFM. Okay, if I win and lose, it's MF and then 1 minus M. Okay, so the probability I beat my mother is M, then the probability that I lose to my mother is 1 minus M. Similarly here, the probability of losing to my mother is 1 minus M, followed by father and mother. And note that all of these things are independent. So I've assumed that if I beat my mother, then the chances that I beat my father are unchanged. So I have some independent results here. So I could just multiply the probabilities for each match. Similarly, if I want to work out the probability that I beat my father, then my mother, then my father, so 3 wins is that probability, FMF. This is FM 1 minus F. And this is 1 minus F. M and then F. Okay, so it turns out that because each of these original situations, win, 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 loss, and loss, win, win, are independent, it means that I can just add these probabilities, okay, to work out So this thing here is the probability that I win 2 games in a row if I play mother, then father, then mother. And this thing here is the probability that I win 2 games in a row if I play father, then mother, then father. So I just have to work out which of these things here, either number 1 or number 2, is bigger. Okay, so, and that's quite simple. Okay, so is MFM plus MF 1 minus M plus 1 minus M FM bigger than the other one? Well, the great news is that this factorizes. So we can write this as MF times M plus 1 minus M plus 1 minus M. And similarly, we can write that the second term that we've just calculated, so this second term here still has a factor of MF here, and then we've got an F plus 1 minus F plus 1 minus F. Okay, so our problem just reduces to working out which of these things is bigger. Okay, so we're going to divide this thing by this thing to work out which is bigger, and we get M plus 1 minus M plus 1 minus M over F plus 1 minus F plus 1 minus F. And when we collect all the terms here, we end up with 2 minus M here, and here we end up with 2 minus F. Okay, so which of these two things is bigger? Is 2 minus M bigger than 2 minus F? Well, we assume that my mother is the better player. Okay, so the probability I beat my mother is less than the probability I beat my father. So we can say that M is less than F, in which case 2 minus M is greater than 2 minus F. So this thing is bigger than this thing, which means that this thing is bigger than this thing, which means that this thing is bigger than this thing, which means that the probability of me winning 2 games in a row is better when I do this thing over here. Okay, so I should play my mother first, and then my father, then my mother, which coincides with the intuition that we should play the stronger player twice. There you go. If you like this puzzle, then we set a puzzle every time we do one of our fun podcasts on mathsat.co.uk. So type that in, have a listen, or download our podcast, Mathsat, from wherever you get your podcasts.